basically introduced by Japanese. And we are focusing on Industry 4.0. We are focusing on how the industry itself, starting from industrial revolutions in 1850, has been changed until now. And now we have Industry 4.0. It means that how we can deal with any kind of IoT technology, big data, as it has been discussed previously by the Australian embassy chancellors, and also by Pak Subandi from Bapenas also. And on the other side, actually, we have also the paradigm for the Society 5.0, which is introduced by Japanese government in this one. In Society 5.0, we are not only looking at the industrial change in our society, but we are looking forward on the change of the how we have any kind of change in our civilization, starting from hunting society until now, what we are talking or usually called as the super smart society itself. And I think both of these trends for Industry 4.0 and Society 5.0, actually they have different points to be emphasized. In Society 5.0, because it is quite inclusive, we are not only looking for the industrial evolutions, for the industrial change, but also for the society change. So we are also looking forward for the cultural change, mindset, and also our change in our habits, or etc., or our mindset itself. So actually, for some Asian countries, I think the idea of Society 5.0 is really much better because it is quite inclusive. We have different ideas in this one. We have different backgrounds. We are not only involving the technology in this case. Technology is a tool, but the most important thing is that how we use this kind of technology, or behind that, we should have any kind of mindset, we should have any kind of backgrounds, cultures, and also maybe for Indonesian case, we have also religions in this case, right? And for the Society 5.0, especially when we are talking about the Japanese cultures, because it is initiated by Japanese governments, there are several walls, bearings, several improvements or developments in our society. The first thing is that related to the wall of the ministries and agencies, this related to the bureaucracy, and also about the legal systems. I think it is quite familiar also with Indonesia. We have also several barriers in our bureaucracy, in our ministerial systems, in our legal systems, and also the wall of technologies. It is including also the technology transfer to all of our people, to all of our citizens in our country. And also the wall of human resources, how we can have any kind of development in the capacity. Okay, as Pak Subandi mentioned previously that from the SDG, we are ranked in 97th from 167 countries. So when we are looking forward, I mean, looking back from the our rankings starting from 2010, something like that, our ranking is not so changing. Okay, so when we are talking about the improvements in our society, especially in Indonesia's case, we are quite lag behind compared with other countries. So I think it is very, very great homework for all of us to how to accelerate this kind of developments. So that's why we can bypass the technology or bypass any kind of developments compared with other countries. And when we are talking about the Industry 4.0 or Society 5.0, they have any kind of big similarity in this case. We are always talking about the big data. Okay, it is also mentioned previously by Australian embassy chancellors about the big data, and also how we process that data. We use any kind of artificial intelligence technology, and finally, also we need any kind of technology to facilitate or to communicate well all this data and also the process data for that. And usually now currently we have 5G technology or 5th generations communication technology in this case. But unfortunately, when we are talking about the big data is not just data. Yeah, and the problems with the big data is that it's involved very huge data, And that's why it deals with any kind of big volumes available, not only in the internet, but also in several server, in several big data servers, or etc. And also the velocity. And the velocity itself is very fast. Okay, yeah, it really depends on the data or the type of data, the data that we want to access or we would like to have. But actually, now currently, the velocity of data is really, really fast. And also the variety. The problems with the variety, and there are many various data available, and how we can get any kind of really true data and also trusted data, and also diversity. And there are kind of some data are in depth, and how to get any kind of the right, true, and also trusted data. That's also very, very important. And when we are talking also about the data, there we have any big data in this case, but unfortunately, all of the data are maybe doesn't have any kind of value. Okay, so that's why how we can use any kind of valuable data, and then after that, during the processings, when we use any kind of artificial intelligence to process the data, we can get any kind of more valuable processed data after that, or process information after that. I think I just would like to skip this one. And when we are talking also about the Industry 4.0 or Society 5.0, and especially in accordance with the sustainable developments as it has been set by UN actually, and also when we would like to have any kind of blueprints in for our country, especially for Indonesia. Actually, I think I don't know whether this kind of classifications can covers all the aspects in Indonesians, but I think there are some important aspects that we would like to, or we must have we must have any kind of development in these aspects. The first thing is about the cities and regions, how we need to develop or to rearrange the development for all of the cities and also regions in Indonesia, and also energy. It is not only dealing with any kind of energy supply, with the quantity that we can supply, but also it deals also with the quality of the energy that we can provide. Okay, so it means that we are not only talking about the capacity of the power generations or any kind of energy resource that we have, but the important thing also is that whether we have any kind of capacity to balance well all of the energy between the supply and also the demands in the same time, in real time in recent case. And the third one, because also we have many disaster, national disaster or domestic disaster in Indonesia, also we need to have any kind of a clear blueprint related to the disaster preventions. And also about the healthcare, about the agricultures, about the logistics. As we could remember that Indonesia has many archipelago, and so it means that we need to have any kind of strong logistic systems for Indonesian's case. And also the manufacturing, how we can develop any kind of manufacturing technology in our country. And so finance and market, it means that market not only accessible by certain peoples or certain citizens, but market which is really accessible and also open to all the stakeholders, including small companies or maybe small stakeholders itself. And also public services. And finally, as has been mentioned previously also by Pak Subandi, related also to tourism. And these 10 aspects should be in accordance with the SDG that has been set by the United Nations previously. And this is the system examples that we would like to have. It is based on the Japanese case, but I think it is just for the examples for the healthcare, how we need to have any kind of integrated systems. Okay, so when some people are going from one hospital to another hospital or being transferred from one clinic to another clinics, there is any kind of integrated data to all of the patients. And also for the mobility, how we need to have any kind of integrated system for the mobility, not only the big systems by train or by any kind of buses, something like that, but also we need to have any kind of more distributed systems for the mobility. And also for the infrastructures, how we need to have any kind of monitoring system for all of the infrastructures. And it will be also strongly correlated with any kind of disaster preventions. And finally, also related to financial and some market technology, whether we can have developed any kind of new fintech and also any kind of accessible online market or etc. I think for the Indonesian case, we have quite good developments in this fintech or also market technology. I just would like to remind to all of us actually, when we are talking about the big data, about the society 5.0, about the digital transformations, about the industry 4.0, the main important thing is that not that the digital transformations, not that the society 5.0 or industry 4.0. In this case, the most important thing is that how we would like to develop the capacity of the citizens of the country. Okay, so digital transformation, DX, or any other IoT technology, big data, artificial intelligence, they are only tools. The most important thing is that how we utilize, how we have any kind of capacity and also cultures, mindset, habits, which can use this kind of digital transformations or any kind of other technology to support what we are targeting for. So we are in this thing, it is very important for us not only develop, not only focusing on this kind of digital transformations technology itself, but also how we need to develop our cultures, our capacity. Okay, and that's why we need to have any kind of clear blueprint in this case. And when we are talking about the stakeholders for our country, especially when we are talking about the institutions which have any kind of responsibility to do any kind of developments, university, or in this case, like Vocational College of UGM itself, we have any kind of opportunity and also responsibility in this case. So what is the responsibility for value creations by the university or by any kind of institutions itself? The first thing, I think there are three main pillars in this case. The first thing is that we need to have any kind of sustainable innovation programs inside the institutions, and also we need to have any kind of discovery and solutions. So it means that for the discovery and solutions, it means that how we need to increase our sensitivity. Okay, we need to be very sensitive to the any kind of problems in the society. New problems maybe not only related to the technology, but also in the economy, in the society, or maybe in other issues actually. And finally, to solve this kind of problems. Okay, so we need to have any kind of problems-oriented solutions in this case, and also to do with that, to maximize that, we need to have any kind of collaborative innovation in this one. So when we have collaborative innovation in this case, we will our targets or our objective in this one is that we need or we would like to amplify the outcomes that we can get from this kind of value creations. And for the institutional task, although we are rooting from any kind of local problems, for any kind of local ideas, but actually when we are talking about the SDG, we are talking about the institutions of university or etc. What we are pursuing for is that we need to have also the global excellence, the global existence in the global stance itself. So it means that we need to clarify our roles in the global developments in this one. And also we need to clarify the grand scenario that we would like to have, not only with the domestic issue, but also with the global issue that we are facing now today. And finally, also with the development of the human resource, which is not only local, but also which is globally competitive. And for the innovations, I think sometimes also I have mentioned this, I have shown any kind of this kind of slides. Actually, we can have or minimally three classified innovations. The first thing is the incremental innovations. Yeah, so we just doing any kind of increment or development from the previous technology or the systems. And the second one, we also have any kind of disruptive innovation, which is maybe it is disruptive. So it means that it when we have any kind of disruptive technology, it means that the previous technology will be not valid over. And also finally, we have also quantum leap in knowledge creation. This is very, very valuable in our society, actually. So for the innovation itself, when we would like to map the innovations happens or occurs in several countries, actually maybe we can map. The first thing is that about the system itself, whether it is closed or opens. On the other hand, we, as I have classified before, that for the innovation itself, we have any kind of incremental or disruptive. By doing this kind of mappings, actually, we can get that, like in Silicon Valley, in US, actually, we can have that they are quite open. They are very, very inclusive to all of the stakeholders, including the university, citizens, and also other institutions. And also, they are very disruptive. It means that they are targeting for creating any kind of new technology. And for Indonesian's case, or maybe Japan case, actually, what really happens currently, or maybe 1 decade before, is that we are still focusing on the incremental innovations. So it means that for the incremental developments, the development of the technology based on the improvements or development from the previous technology. So we are not moving for the in disruptive innovations, but still in the incremental or step-by-step developments. And also the system itself is quite close. So it means that all of each institutions, they have their own development. They have their own policy for development itself. So what we would like to have is actually, I think, disruptive and also open innovation, open systems will be quite best for supporting the innovations in our futures. And when we are talking about the sustainability in science and technology, what we need to have actually, the first thing is that related to solutions-oriented research and innovations. It is the main task for all of us. So we are not only talking about the paper-oriented or any kind of, I don't know, like another orientations. But the most important is that when we have any kind of sensitivity and we discover or we find any kind of problems in our society, and at that point, we would like to have any kind of solutions that we would like to provide to give or to provide the solutions to that problems. But actually, although these kind of problems are faced by local areas, but actually when we are talking about the innovation, we are talking about the knowledge creation itself, we are talking not about the local values, we are talking about the global values that we can provide. And also what we need, as I mentioned previously, that we have 3 classifications in the innovations, but I think the most important thing is that although it is very hard to all of us, the quantum leap innovations, which is driven by any kind of basic science, also very important. So we are not only talking about the incremental innovations always. So in this case, when we have any kind of disruptive and also quantum leap innovations, it means that we can have any kind of bypass improvements in our society compared with other countries. And also we need to have any kind of collaborations and also multi-ways dialogue among different stakeholders, including industries, governments, academia, and also society. And finally, which one is really important is that the capacity buildings. Capacity buildings is very important for all of us. So we are not only talking about the capacity for doing any kind of technical task or any kind of knowledge or something like that, but the capacity which is really, really comprehensive. We are talking about the cultures, we are talking about the habits, we are talking about the mindset, we are also talking about the technical capacity that we would like to have. And what we are targeting for is that when we would like to have any kind of innovations, which is inclusive and also comprehensive in one country, what we like to have is that how we can create any kind of open innovations to all of our society. And we would like to target or facilitate or obtain any kind of open innovations in our society. I think there are 3 main steps which we would like to have. The first thing is that it is related to the building scenarios. So I think in this one, the most important thing is that we need to clarify the grand design, also means scenarios. So we are talking about the blueprints. So the big blueprints in our society, whether it is country or maybe regions. So it means that when we have any kind of clear grand designs or main scenarios, it means that all of the stakeholders, they can have factors which is directing in the same directions. So it means that we can have any kind of positive or resultants or total resultants from our factors, which is really strengthening each other. And also the second step is that also we need to analyze and also clarify the key technologies that we really need to have. And also finally, it is correlated also the capacity buildings, which is dealing with any kind of knowledge transfer that we need to do, whether it is inside the university or maybe inside any other institutions. And the second step is that forming the collaboration platform. So we are dealing more technicals in this one. So in this case, so we need to have any kind of platform or consortiums which can facilitate any kind of mutual co-creations. So we are not only talking about the collaborations further, we are talking about how we have any kind of co-creations together. So it means that in this case, we are not only talking, okay, we are joining together, so we are collaborating to initiate or maybe to achieve any kind of target, something like that. But how we need to have any kind of benefit, mutual benefit from to all of our stakeholders. And finally, after that, after clarifying or maybe developing any kind of platform, finally we are doing any kind of realizations from the collaborative innovations. And this is the open innovation platform we need to have. Okay, so but I think from this one, the most important is that that we are talking about the cultures, but the awareness of the problems, and also awareness to give any kind of mutual benefits, mutual advantages to all of the stakeholders over years. And okay, I think this is the mechanism to promote open innovations. Okay, this is the when we are talking especially university as the institutions which can facilitate any kind of mutual collaboration or mutual communication among different stakeholders. In this case, I think the university is the best place to provide or to facilitate this kind of communications. So doing any kind of joint or collaborative or maybe co-creative research between the industry, academia, governments, and also society or community is very important to be any kind of task for the university itself. And also, this is the outlook toward the university industry collaborations. So what we need to have in our university. So in this case, we need, the first thing is that we need to clarify the blueprints, the scenarios also, and we need to facilitate any kind of large-scale joint research collaboration among the university, governments, industry, and also community. So this is not only limited to certain stakeholders, but how we have any kind of more inclusive, also comprehensive collaborations among different stakeholders. And also we need to have grand scenario, clear grand scenario, including the targets or including the purpose or objectives of the collaboration itself. And also we need also to transfer the technology, to transfer the knowledge. It means that we need to cultivate the diverse young mid-career researchers and also maybe another engineers or etc. And also about the mobility and also about the fundings or etc. Okay, so collaboration is really a process. It is not the final result. It is a process actually. So what we need to be aware with this one is that it is really a process. It's like the phase change of the waters. It goes from the preheatings, phase changing, also superheatings. Unfortunately, the biggest effort for the collaboration itself is during the phase changing itself. So we need to understand, so mutually understand between the correlated partners or our stakeholders during the collaboration itself. And I think this is the collaborations, which is the main target of the collaboration is the capacity buildings. This is very important. We are not only targeting to to achieve or to realize the objective of that projects. But the most important thing is that how far we can build our capacity together. And this, like in Japan, actually, there are some philosophy related to this one. We are moving from any kind of join. We are working together. We are joining any kind of programs, and also we are after that we are moving to the collaborations. It means that we work together to achieve any kind of purpose, any kind of objectives, or etc. But further, what we need to have is the co-creation itself. It means that we need to have always mutual advantageous creations among the stakeholders in the collaborations itself. And I think this is the schemes for the collaborative research with industry. I think I would like to skip in this ones when we are talking about the energy, because my background is also technology, because it is also my time I think is over. But I think I just would like 1 or 2 minutes for ending my presentations today. It is correlated with sustainability in the energy issue. It means that when we are talking about the energy is very important for our life actually. When we are talking about the sustainability in the energy system, it means that minimally we are having 3 main pillars. The first is about the energy security, and the second thing is about the energy equity. And finally, it is about the environmental sustainability. When we are talking about the security, we are not only talking about the capacity or about the quantity of the energy that they can provide, but as I mentioned before, that it's also correlated with the capacity or the capability to provide any kind of good energy or balanced energy systems in our society. So we are dealing with also with the quality of the energy that can provide, including the electricity. And also the second point is related to the energy equity. It means that how far we can provide, facilitate any kind of open and also accessible opportunities to all of the stakeholders. The stakeholders not only being the consumers, but in the futures, maybe all of the stakeholders will be any kind of producers and also consumers in the same time. So it means that we need to have any kind of producer and also consumer in this simultaneously. And also finally, it is correlated with the environmental sustainability related to the CO2 emissions, climate change, or also environmental sustainability, or etc. Okay, so because of the time, so I just would like to skip these ones, but actually during the COVID-19 pandemic, starting from 2019, at the end of 2019, and it's continued to 2020, actually the electricity or energy demand in our society globally also decreases accordingly. Actually, the mobility also decreases, the energy consumption also decreases. And also what we are having now currently is related to the GH emissions, which is including the CO2, methane, or etc. We have good news in this thing is that the total emitted CO2 or GHG in our atmosphere is really decreasing now. Starting from about 38 gigaton of CO2 per year, we are now facing about 35 gigaton of CO2. So it means that we have 4 gigaton of decrease or reductions of CO2 globally. So, but unfortunately, it really depends on our mindset and our behavior after this one. Whether we would like to have any kind of more sustained technology or more sustained conditions in the futures. Okay, so it means that we can have still lower CO2 emissions in our atmosphere, or we would like to return back to our cultures, to our habits previously. So it means that we would like to have, as the result, we would like to have any kind of increase in our emitted CO2 amount globally. Okay, so thank you very much for all of your attentions today. So in case that we have any kind of discussions, I really welcome for that. Thank you very much, Pak Irfan, and hopefully we can have any kind of good chat and or maybe discussion further. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the presentation, Prof. Muhammad Aziz. Quite interesting topic. Is there any question or who want to ask directly about the presentation by Prof. Muhammad Aziz? if there is no question, I would like to ask a question, Prof. Right now, Indonesia is in like incremental innovation, not the disruptive innovation. What is the most important step we need to take to move the Indonesian maybe behavior or characteristic from incremental innovation to disruptive innovation? Thank you, Prof.
Okay, thank you very much, Pak Irfan. Actually, incremental innovation is not bad. Okay, incremental innovation is also good points. Like when we are okay, we are talking about Japanese case actually. Japanese case basically we have any kind of incremental innovation also, but it is really step-by-step incremental innovations. And in case that for the like car technology, okay, like the vehicle technology. Finally, Japan can have very efficient engines for that compared with the United States, which notably they introduced first, or they found first or developed first the engine itself. Okay, but actually now also in recent things, also we have any kind of disruptive innovation, including the fintech innovations like GoPay, Gojek, or everything, and also for the market technology, including the Shopee, including any kind of market platforms in Indonesia. But I think that's technology is quite disruptive, you know. So it means that it is really changes the behaviors, or really changes the conditions that we have previously. So the main things what really need to have in the futures is that in case that it is really incremental, how we can accelerate that. So we just not only following the developments on the technology by other countries. So actually, like okay, talking about the technology for the electric vehicles, for the energy, or maybe for the battery, we are not only trying to follow the technology by other countries, but how we bypass this kind of technology. Okay, so it means that accelerated incremental innovation is also very important, and I think that the best thing that maybe we can have with our capacity today. Or on the other hand, also we need also to focus on the disruptive innovations to accelerate also the development that we can have in our country. Actually, thank you very much, Pak Irfan.
Okay, thank you, Prof, for the answer. Okay, interesting. Japan is already also incremental. That can be classified as incremental innovative, but they can strengthen the advantage in terms of like automotive technology, like car. And is there any question? Another question for the participant regarding this interesting topic?
Hello. Can you hear me? Actually, I'm very impressed about your presentation. I like that your presentation, and I'm very curious about the industry and the economy in Indonesia. I'm sorry, I'm talking from Japan. My name is Kato from NIT. And what do you think about the future? I'm thinking about the EV in Indonesia. EV will be very spread in Indonesia quickly, or it will take a time? I'm very curious about it.
Okay, thank you very much, Kato Sensei. Okay, thank you very much for your very nice questions. Actually, I think because my base is in Japan in Tokyo University, so I think I don't have any kind of rights to answer completely or truly on your questions. But I think when we are also, actually, we are collaborating also with our partners in Indonesia on the EV technology in this case. But I think the EV technology in Indonesia is still quite far. I mean, we are still having or facing several problems in this case. The first one is related to the technology itself. Okay, now we have several projects in Indonesia related to EV itself, but basically this kind of technology, I think, still very basics. So we need further to improve this kind or accelerate this kind of development or improvements or R&D for our electric vehicles also. And the second thing is that also related to the resources or capacity, although we have materials for the electric vehicles, especially for the battery itself, like nickel resources or etc. But unfortunately, the technology to convert or to utilize well this kind of materials still also quite far. And now that's why we are now still trying to push and some industries to join us for developing this kind of resources to be utilized or to accelerate these EV developments in our countries. And also the third point also related to the energy that we have now currently. Actually, although the capacity of the power in Indonesia is now maybe from the capacity point of view, maybe it is sufficient. From the terms of watt hours, but unfortunately, when we are talking about the charging behaviors of the EV, something like that, actually we need very, very responsive capacity or capability of the grid to balance the grid conditions. Otherwise, we will have any kind of accidents. We will have any kind of blackout in our energy in our grid actually. So that's why I think currently related to the electricity, we don't have any kind of large-scale energy storage or electricity storage, unfortunately. Like in Japan, we have pumped hydro, about 20% of capacity. But in Indonesia, we still, until now, we don't have any kind of pumped hydro storage or maybe any kind of large-scale electric power storage for our energy system. So that's why. So I think that three big concerns. I think we need to really aware for this one. And also after that, maybe we need to accelerate the technology that we need to have in the future to accelerate the EV developments or EV adoptions in Indonesia. Thank you very much.
Thank you, Kato Sensei and Aziz Sensei also. Okay, I think we have one more question. We also have 1 minute. 1 more minute. The question is from Trihastuti, UGM. Based on slide number 6, 10, and 11, and 24, what kind of energy policy, especially nuclear use from Japan, can be accommodated by Indonesia to support sustainable development? Please,
okay.
Aziz Sensei.
Okay, it is really sensitive issue for me actually. I mean the condition is quite different. Okay, for Japanese case, okay, now currently we are running for about 6% of the total capacity used by the nuclear powers, and actually after clearing all the required documents or required testings or validations or etc. Japanese government would like to return back the capacity to about 15 to 20% of the total capacity of the electricity. Okay. For Indonesian case, this case is very, very sensitive. It is not only social, but it's also very political for my case. But actually, also because I'm dealing also with energy systems as my research. Sometimes, I think for Indonesian case, we have several different scenarios for our case actually. Whether until now actually the projects for the nuclear power development in Indonesia always been rejected, whether it is by society, by local society surrounding the area, or maybe by politicians. So that's why we need to move on other scenarios. The first scenario is to have any kind of more, I think, small scales nuclear power plants for this case. Actually, like Indonesians, as I know that basically now also we have two different, I don't know, correct me if I'm wrong, actually. We have also several nuclear power plants in Indonesia, although it is used for research purpose. It is in Tangerang, in Serpong, and also in Yogyakarta also, I think. But the capacity is very small. It's about 30 megawatts, something like that. So in case they would like to have any kind of any kind of nuclear power power plant in Indonesia, it means that I think more smaller scales of the nuclear power plants will be quite more promising. So I think we can minimize any kind of rejection from the society surrounding the projects, or also by the politician itself. As we know also that the nuclear technology is not a standalone technology. So we cannot lay on the people working on that only, but it is any kind of integral or integrated technology or integrated knowledge itself. So in case that something happens or some fault happens in the nuclear power plant, so it means that we need to have any kind of very, very responsive system to tackle down this kind of accidents or tackle down any kind of problems following that. And also another scenario is that maybe we can install also this kind of nuclear power plant in our remote area, and then we can convert this kind of generated power or generated energy from the nuclear power plants to any kind of secondary energy sources, including hydrogens, ammonia, methanol, or etc. maybe. And then we can deliver this kind of secondary energy sources or fuels to any other island. So it means that in case there is, so it means that okay, we have any kind of remote islands in Indonesia, many. So it means that maybe inhabited islands. So in this case,
me, Prof.
Yeah.
The time.
Okay.
Unfortunately,
so maybe we need to develop this kind of two different scenarios in our country. Actually, thank you very much.
Thank you, Aziz Sensei and Kato Sensei. The time is up, but actually the discussion is quite interesting. Many topics can be discussed related to the materials. Thank you very much for the presentation. Before we move to the second presentation, I would like to take photo. And also, I would like to welcome Prof. Saiful. Welcome, Prof. Saiful.
Yeah, thank you, Irfan.
Okay. Because we already, I think we can have like a photo session first before we move to the second speaker. Miss Pandan, can you help me to take a photo for all the speaker and participants? Please turn on your camera before we move to the next speaker. Okay. Okay. 1, 2, 3. Please give us already done, Miss Pandan. If already done, you already have a screenshot. Let me know.
Sorry, Mr. Bahiuddin, I will help Pandan in here to take the photos. Here I'm Demas. I'm the one of the co-hosts in here.
Okay,
so I will
okay.
help. Okay.
Okay.
Okay, ladies and gentlemen, please turn on your camera, and then there will be 4 slides in here. It's already okay. Please turn on, and then I will count it. 1, 2, 3. Okay, next. 1, 2, 3. Next. 1, 2, 3. The last one. 1, 2, 3.
Okay, thank you, Mr. Dimas. Okay, let's move to the second presenter. I would like welcome Prof. Saiful Amri Mazlan. I will read his curriculum vitae. Prof. Mazlan is currently a professor at Malaysia Japan International Institute of Technology in Universiti Teknologi Malaysia and also a visiting professor at Tokyo City University, Japan. He is a registered professional engineer with Boards Engineer Malaysia. He holds a doctorate degree from Dublin City University, Ireland. His research is primarily in the area of smart materials such as magnetrological materials, magnetrological fluids, elastomer, and so on, and also its application. He has published about 125 peer-reviewed international journal papers, and also 54 paper proceedings and 50 book series and chapters. He has also received various awards, such as Outstanding Technical Paper Award given by Society of Automotive Engineers, or SAE International Malaysia in 2018, and also 2020, Distinguished Scientist for the Contribution and Achievement in the Field of Smart Material in 2019 from Center of Advanced Research and Design, Venus International Foundation, and also he obtained a gold prize at ICANN Toronto, Canada 2018. And also for the participant, if you have question, feel free to ask in the chat provided by Zoom. And also don't forget to mention your name and affiliation. And for Prof. Saiful, you have like 25 minutes for presentation and 10 minutes for Q&A session. Okay, without further ado, let's welcome Prof. Saiful. The time is yours.
Yes, Assalamualaikum warahmatullahi wabarakatuh, and very good morning in Indonesia, and maybe in Malaysia it's good afternoon, and Japan also, I think. Okay, my name is Saiful Amri Mazlan. As you know, I'm from Malaysia, Japan International Institute of Technology. It's one faculty under University Teknologi Malaysia. Before that, thank you, Dr. Irfan. He was my ex-student for PhD and master last time. Okay, we hear that there is a lot of, aligned with this conference for sustainable. I think we are discussing a very heavy topic. Okay, well, but for my topic right now, I want to discuss about something that whatever your research that you can contribute to the sustainable. This is what I think we want to do. Sometimes we think that we have something, but how we can use that, utilize that our funding in order to achieve the goal for SDGs. Okay, in fact, I'm not really responsible for the big role. I'm only a small person with my research. So I would like to talk about. There is one new material, we call it magnetorheological material. It's for the future smart devices. I know this is less, it's not many products that use this material, but this is the future of the material itself. Okay, just for the introduction about the university, Malaysia, Japan International University, actually we have a collaboration. We collaborate until now. Actually, we have 30 members from Japan. So you can see there's a lot of the university and institute from Japan itself that we contribute. We have some kind of the collaboration in terms of the research, in terms of, I mean, a lot regarding the research. Okay, and then we have a team for this. We call it COSA. In Japan, it's research group. So we have 4 persons. This is the key person for the magnetorheological materials. You can see only 4%, but we cover quite a lot. I will show you later on what we have done. We have covered the material development, devices, and system integration. Okay, as an introduction, actually, what is magnetorheological material actually? This is under the smart material where it's capable of reacting to external stimuli by changing its material properties for the desired way and effectively respond to these stimuli. Okay, we can have stress, temperature, moisture, pH, electric, and magnetic field. Okay, this is the concept of the smart material. They can respond to other external anything that can change the material behavior. So for the MR material, I call it MR, you know, easy to say that. And then this is about the magnetic field responsive material. So we have the magnet, how the magnet itself can change the behavior or the properties of the material. So under the MR material, we have three form of state. We have a liquid, semi-solid, and solid. Okay, this is the basic one, and then later on we can go for the how to apply for this kind of material. Okay, so under the liquid, we have another two categories that we call it liquid or grease, which is the liquid is okay. We know that this the liquid is behaves like a liquid, but after the liquid, we have the grease type. This is between liquid and semi-solid. We have the liquid, but we have just solid particle, a solid. We have the solid in the liquid. So then we have the semi-solid, plastomer. We have the elastomer and form. Okay, all these things we can convert the passive state to become at least for the semi-active. Okay, and this is the basic of the operation. We have to know that because this of the magnetic stimuli, we have to know exactly where's the direction of magnet field, so that, and then where is the working effective working area. So we can have the flow mode, which is the force is perpendicular to the magnetic field. We have the shear mode, which is one of the stationary plate or something that move, and then we have the squeeze when we squeeze it, and then we have the gradient pitch mode. This is just a manipulation of magnetic field. Or we can have the mix mode, which is we can combine between two. This is very important to design the device later on. So we have to know where is the effective area, what is the effective, where is the direction of magnetic field, and then working direction, so that we can come out with something that useful for to be utilized. Okay, I go for the first form of the MR material is a magnetorheological fluid. This is the fluid type. This is very established. The basic concept of this one is something like when we have the magnet, there's a ion particle inside the liquid that will move and according to the magnetic field, so that we can act as a barrier, which is the flow of the liquid can be restricted by the magnetic field. So we can change the behavior of the liquid. So this is one kind of the MR fluid. So this is, I give you the example, when we develop a damper, we can play or we can generate a higher damping properties by having increase the magnetic field, which is we can increase the magnetic field by using electromagnetic. So normally we use the electromagnetic circuit, so that we measure the current that going inside, so that we can give a higher magnetic field. This is how it works. So meaning that for a normal case, we can have the adjustable or semi-active for, let's say for this case, for the damper, for the lower and to the high by using only one device. So we can control it before something like this is the very minimum, which is zero magnetic field. It still can function, but after we increase the magnetic field, it can become a very high performance, a very stiff. Okay, this is what we are looking for. So meaning that we can change the property from less stiff to higher stiff, very high stiff. Okay, and then this is one. This is some of the example. You can see this is some the damper itself, the building for the bridges. There's I think it's quite a number of that one. And then this is, if you can see the damper here, the yellow one. This is actually they built it in 101. I think this is in Taiwan. One of the higher buildings there. This is see how many damper they use it for actually to come out with this. And then this is the design. Okay, now this is quite established. Even in the automotive, you can see under Delphi magnoride, they already have this damper to be used in a lot of the models. But this is of all high-end car. You can see there is Lamborghini, Ferrari. Okay, but by doing this one, it works, but very expensive. We try to simplify this one and we want to increase the performance. So in the case of MR fluid, what have done, instead of having the existing MR damper, actually this is in the design itself, where the we control on the piston itself. We introduce the valve actually to be a stationary or static at the bottom of the damper. So you can see on the right side, this is the prototype of this one. Actually, we developed with one of the local car manufacturer in Malaysia. It's still under development. But how we do it, we try to change the concept from the piston itself. We still have piston, but we don't control the behavior of the MR fluid using the piston, but we introduce a valve for that. And then we can have a better performance than existing one. This is one of the example of the product that we try to develop. Okay, then we go to the MR grease. Okay, this is grease. Just now is MR fluid. The problem of MR fluid, they can have a very high force, yield stress, but the big problem is sedimentation and leaking. This is the two big problem. So that we introduce MR grease, whereas we try to have a different medium of the liquid. So the composition of MR includes magnetic particles, still the magnetic particles, and the grease as medium. We use the grease, and then by doing this one, we can solve the sedimentation problem, and then it can act as a sealant. But the problem is the yield stress is lower than the MR fluid. So this is the concept. You see, you can see the one with no magnetic field. It's something like it's randomed in, and then with magnetic field, and how the properties change inside the grease itself. Okay, this is one. Okay, when we can have a very high yield stress, we try to introduce this material to other product or other device that we can control, but the small that requires small stress, yield stress. I mean, okay, this is one of example, compact MR brake. We have this small brake. Looks like complicated. Actually, this is not complicated. And then we have the grease inside. We can manipulate the grease behavior. Then, where to use it? We try to introduce this brake system in the, we call it, what is it, autosys in the rehabilitation, where we can control the angle. When there is, what is called it, the anchor position, especially after stroke, or normally for the patient with after stroke, they have to learn how to walk again. And then this is how the brake assists actually for the ankle position. Okay, we have done this project still under prototype. I think there's a lot on the prototype development. And then, okay, we come up with another kind of material. We call it a magnetorheological plastomer. Okay, this plastomer actually, they have a different concept with grease, slightly higher density, but the best thing of the plastomer, we can control the shape. We can shape it according to the mold. It can sustain there, but maybe not for long. But at least they can sustain, and then they can have something like a very unique characteristic. Okay, this is again we use the iron into a plastic polymer matrix, and then with magnetic field, the iron defeat the polymer obstacle to form chain structure, thereby producing this is entropic MRPs. And then the same concept, the same thing, but we can manipulate the behavior according to the shape. Okay, this is like grease, but it's kind of hard form, or the grease is soft form. Okay, I want to show you some. This is what we have done to the MR blastoma. It's really respond to the magnetic field. Okay, this is a good thing about this one. This is without the magnetic field. You can see the material is break, is at certain level. But when we put it the magnetic, this is in this case a permanent magnet on the top and bottom. Actually, you can see the left side. It can be longer than that, much longer than without the magnetic field. Is it responsive? This is some of the application for this one. You can see this is for the sensor, energy absorber, and can be used as a drug delivery as well. Okay, while doing that, we have the magnetic field. We can see that is the we can benefit from the finding. We try to introduce what we can do for the conductivity. I mean, with something that we can use the same material for the conductivity. So we just put it some of the material that conductor material, and then we want to test what will happen, you know, for the conductivity about the resistance. Okay, maybe you can see this one. Okay, we just try to measure, you know, what is the resistance of this one. You see, we use the battery, and then you see the light. It can generate. In fact, take it longer, and then very long is reduce the amount of light. Oh, sorry. So the plasma just now is still new material actually. Now we can have the two unique characteristic. One is normal like MR material, and another two conductivity. Okay, this is something that we can do. We have some idea for this one, but it's still under, you know, we are looking for the collaborator to come up with a good idea to develop the idea further. Okay, another form of MR material, we have the nectarological elastomer. Okay, this is a solid form. It's very hard. It's made by either silicon or natural rubber. So this is mainly we monitor the fabrication of the material. It's either anisotropic or isotropic, which is the isotropic is just leave it like that, it's randomly. distributed particle, and for any isotropic during their vulcanization, we give the magnetic field so that we can have that particle aligned before it cured, meaning that this is something like the composite material. So that for this one, normally the MR elastomer cater for the vibration or noise. This is, I think, many researchers doing that, especially for the vibration. And then we have the prosthetic leg. This is some of the sensor regarding sensor devices, and then it also can become a actuator. Okay, example, this is what we have studied on the prototype on, this is isolator actually. We have a kind of the design, we have the multiple steel here to generate magnetic field, not to guide the magnetic field actually. So initial result, we can have the different stiffness that we can control the stiffness. This is good for the, what we call it, for the earthquake, seismic damper. And then, I think this is okay. Oh, sorry. I'm sorry for this one. Okay, this is another one. We go for the automotive, and we try to develop MR bushing. Simple one is under very initial study, and then from this one also we can see there are various of the stiffness. This is very good for the bushing, especially after this I can show you the engine mount. Also we develop this one. We have a big problem for the car, especially for the electric, stop start car. When the car stop, after the car stop then start, you can see a very big vibration for the car. This is very obvious, and I think nobody can solve this problem. So by this one, we hope that we can at least reduce the vibration. And then the same thing happened to MR plastomer. We put it the, what we call it, the conductor material. Then we can see there's a relationship actually between the force, displacement that come from the force, and then the magnetic field. The magnetic field can generate the stiffness of the material and the conductivity. Okay, we can have the force here, we can have displacement because of the force, and then we can have the magnetic field that control the stiffness of the material. Okay, this is good for the sensor actually. We're still developing on this one. The concept is there. Okay, this is how we try to put it this way. We try to develop the sensor, actually the force sensor. So we have the force, magnetic field. This is the graph. Okay, now we put it with different force for this kind of material, and with some of the magnetic field, we can see the resistance is reducing. And actually, this can be a force sensor that can be, this is one of the example of the application, and we can manipulate the force, what is the force, and then what is the resistance come from the force. Okay, I think this is the last one. We have the foam. Foam is a sponge type. There is two kind of foam. We have the rigid foam and the flexible foam. For this kind of material, we can cater for another application. Okay, this is the basic of the MR foam. You can see the convenient foam. We can have the strut there and the pore. But with MR foam, we can see the particle feeding the strut actually. And then they have a pore there. Okay, this is controllable. We can control the stiffness of the material. It's lightweight, of course. It's sponge type because there's a lot of air and excellent vibration, acoustic absorbing. Okay, this is where we want to try for this kind of material. Okay, we try on the sound absorption effect. We can see that magnetic field actually related to the shape. We can have a different shape, not different shape actually. We can change the normally a spherical shape to something like oblong loop like shape, because when we have magnetic field, the particle will try to align with the magnetic field. So actually the sound does have affected by the shape of the ball. So with this one, at least we can control the sound. Okay, this is some of the example for this one.
Sound insulation is a common technology being used. This is because human limit noise level is 70 decibels, and continued exposure will eventually harm your hearing. So, sound insulation creates sound damping that helps reduce the transfer of noise. The idea is by using double layer or thick and denser building materials that cost you thousands to build sound.
Excuse me, Prof. The time almost running up.
Okay. I think this is the last one. Sorry.
Double layer or thick and denser building materials that cost you thousands to build sound.
Okay, I don't know how to do. Okay, that is the one of the MR foam. But there is another properties for the MR foam, which is we can have the magnetostrictive effect. By having the magnetic field, we can change the shape of the material itself. Normally, for magnetostrictive material, the researchers, they study on the Technologi. It's very high frequency and a very little of the displacement. But this one you can have the soft and a very big displacement for MR foam. Okay, some of the application. This is what we can use for the touch sensor actually. And then okay, as a conclusion, we can have the many type of this material. We have the fluid, we have the grease, we have the elastomer form and plastomer. This is 5 kind of the type, and then this is what we study on this one: how to increase the performance, how to make sure that it's durable. And then we have the value added. We have also many things. We have the design concept, magnetic field, simulation. We have the process condition, vulcanization, and application. Also, we have a lot of application. This is some of the application. We can see this rubber bearing, isolator, and then some of the automotive rehabilitation. And then the last one is the opportunities. We can see that on the MR fluid, more on the product development. I mean, the fluid itself is quite established, and the grease, we can utilize the benefit of the sealant of the application. And then also, I think this for the electric properties also, we try to introduce this to MR grease. Elastomer, okay, this is mainly this is a very huge market for this. And then we can also this one for sensor, plastomer. We are thinking about the education teaching first, how to play with this one. This is a toys, it's a plasticine actually. And then we have the form for sensor, actuator, and some absorption. We have to further develop this one. Okay, I think with that one, thank you very much. And you are free to ask any question. The one that I can answer, I will answer. Thank you. Back to you, Dr. Irfan.
Okay, thank you, Prof. Saiful. Quite interesting materials. I'm sorry, I use another device, so I need, because my computer is crashed, so I can use the virtual background. Okay, feel free to ask using chat, or anyone who want to ask directly. Feel free, please let me know. Okay, while waiting the question from the participant, Prof, I would like to ask, the material is quite interesting, so it can change the stiffness. The stiffness can be changed with the presence of magnetic field. And the application already we know that in the already explained before, that the application including in the car, in the automotive, and also in the medical devices. In which field the material have been already applied, and in which potential field it can be also applied, Prof.
Okay, thank you. Very interesting. I think actually I have a dream of where to utilize this material. In every device or product that use as a damping, that you want to utilize the damping properties. That's why I said let's say the isolator, you can see the bridges, you can see a lot of bridges, you know, they used to isolate that one in the building, especially at the country that you experience the seismic, you know. I've been in Tokyo City for 4 months in Tokyo City University, and I experienced I think it's quite big earthquake there. You can see, you know, something like you are in the boat. And then in every that vibrate, this is for the MR elastomer. We can change that one, and then we can prolong the usage of the material itself rather than we can have the passive one. As we know, the material will degrade over time, especially under the weather effect. So with this one, at least at very least we can sustain the performance of the one for a very long, or we can change for what we call it. We can enhance the performance of that one. Okay, this is the one. And then for the MR form itself, for the sound, and then it's very this is a very new thing. And then without realizing, we can benefit this one into many. Actually, it's a daily day. You can see there's a lot of things that you can change, and then it's not very expensive and very simple to produce that one, and then very simple to monitor that one. I hope that in future we can use this.
Okay, Prof. The device. How about if we want to apply in building in Indonesia, because Indonesia have like many recorded earthquake, because there are many volcanoes, and also because the tectonic cause. How is the potential to be applied in Indonesia in terms of in building?
Okay, thank you. In building, I think the best thing is for the isolator. Okay, for the form, I think, and then we just figure out that this kind of material also it can act as a filter. I mean, in terms of the filtering the air, you know, some of the waste of even for the oil, it can absorb certain thing. We just discover this one, me and my partner, I mean my team. Then I think it can be used into that one. But normally for the building, we have a 2 type. One MR damper itself is that one is very for the seismic, and another one is the isolator with the MR elastomer. So both of that one, normally some of the country they have the criteria for the building before you. I think in Malaysia also they want to try to initiate this initiative. Above than I think 17th floor, we must have to install damper actually to cater if something for the seismic normally. That's what I can think now.
Thank you, Prof. Is there any question anyone want to ask directly to Prof. Saiful? We still have maybe 1 minute or 2 minutes more. Is there any?
Assalamualaikum and very good afternoon. I have a simple question. I would like to ask Prof. Whether how do we compare that as you mentioned just now, the performance of the MRE isolator in seismic retrofitting is quite obvious that we can actually implement it in seismic retrofitting. But how can we say that it is more cost effective, or maybe it is better than the conventional isolators that we already have and it's already well established. So how can we say that by using this MRE or MR elastoma, it is better? Thank you.
Okay, as we know, what we have done, I think many of country they install actually the damper and a passive damper and the passive isolator. I call it passive because you install it once, and then we never know what will happen, and then what's the impact for that one? What is high for the high impact for the damper itself or the isolator? But for this one at least, actually we can connect this one with the input. So we have the sensor. That one is this is how to utilize this material, so that from the input we can adjust the stiffness, and then we can adjust what is the damping performance, what is the damping characteristic for this one, and then we can at least they can absorb for the real time. Okay, on that one, and then even for the performance, let's say we, as I said just now, is for the how durable is the material. Okay, I give you one example. Let's say for the bridges, when you install one damper isolator in between the top, I don't know, is it the top bridge and the column? This is a very big damper there. We call it isolator. And then for how long it can stay? It's sustained there. Maybe 10, 15 years after that, you have to change so that you can have the same performance of the material. But by having the MR elastomer, at least we can maintain the performance of the device. Let's say it's degrade, we can increase back by using the M.Phil. This is one of the how we prolong the lifespan of the material. And then it's more durable. Yeah, I think this can answer you.
Okay, thank you, Prof. So it can prolong the device. So maybe in terms of the price, it's more expensive, but in terms of life expectation, maybe it can be longer. Okay, it is interesting topic, but we already the time is already up. And thank you again, Prof. Saiful, Amri, Mazlan, and also thank you for Prof. Aziz. We have reached in the end of the session, and after this, we will have a short break until 1 p.m. 1 p.m. o'clock. So we will continue the parallel session, and then we already taking the photo session. So I think it's already enough, and I will end this session with. Is there any notification from the committee? So I think there is no announcement. So we will continue the parallel session in 1 p.m. Using this room and also several rooms for the science and technology cluster. And then thank you all for the participants, for the presenters, for our prominent speakers, Prof. Saiful Amri Mazlan, and also Prof. Muhammad Aziz. And wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Irfan.
Waalaikumsalam warahmatullahi wabarakatuh.
Saiful, also thank you very much for today.
Yeah.
Very nice talk.
Okay. How is Malaysia, Prof? The COVID? Is it
It's getting worse.
Getting worse.
You can see there's a very spike the numbers. No, every day is now about above 15,000 a day.
Okay, but still, Indonesia I think worse.
We have to.
Japan I think can handle. I think.
Yeah, Japan now currently I think about 3,000 per day, something like that. I think.
How's the Olympic there?
Yeah, Olympic is going now. Yeah, everything's fine with Olympics, but we don't know actually what really happens. Maybe for some of this after, we don't know. Yeah, it seems good for the Olympic.
You should watch that, at least. Present, very interesting.
We cannot watch, unfortunately, so there's no spectators over there.
Yeah. Okay, so thank you very much, and see you at 1 o'clock, Irfan. Yeah, thanks.
Okay.
Bye.
Okay, thanks, Pak Irfan.
Okay.
Also, Pak Saiful. Thank you very much, Prof. Saiful, and everyone over here.
Okay, Prof. Aziz and Prof. Saiful, thank you for coming, for accepting our invitation. Hopefully, we can collaborate more in the future.
Sure. Thank you very much. Assalamualaikum.
Assalamualaikum.
Waalaikumsalam. Okay, it is the schedule you see here for the participant. You're welcome, Kato Sensei. Oke, terima kasih banyak. Oke. Using Indonesia.
Terima kasih.